This is my 6th video lesson for Unit 14. This lesson is part 2 of analyzing a Voltaic cell. Go to page 23 in the class packet. For motivation, take a moment to analyze the cell diagram. Learning target. At the end of the lesson, I'll be able to explain the purpose of a salt bridge and the flow of charged particles. Homework is number 6, which will be a Junipod based off this lesson. A cell diagram is a shorthand notation to describe a Voltaic cell. This diagram is used to illustrate the redox reaction in a Voltaic cell. On the left is the anode. The zinc is being oxidized to zinc positive 2. On the right is the cathode. Copper 2 plus is being reduced to copper solid. Electrons flow from the anode to the cathode. These two lines in the middle represent the salt bridge. Learning check number 1. A Voltaic cell is set up using the system below, which is the anode. Pause the video, resume as completed. The anode is written on the left. Aluminum is being oxidized to aluminum positive 3, so the answer is choice 1. Learning check number 2. A Voltaic cell is set up using the system below. What is produced at the anode? Pause the video, resume as completed. Since aluminum is being oxidized, the product is aluminum positive 3, so the answer is choice 2. Learning check number 3. A Voltaic cell is set up using the system below. What reaction takes place at the cathode? Pause the video, resume as completed. The cathode is written on the right side of a cell diagram. Gold positive 3 is being reduced. It gains 3 electrons, so the best answer is choice 3. In practice number 1, write the cell diagram based off the equation. Pause the video, resume as completed. Here are the answers. In the next part of the lesson, we will further analyze a Voltaic cell. We will focus on the change in mass of electrodes, why is the salt bridge needed, and which ions go through the salt bridge. Let's first look at simulation of a Voltaic cell. Pay attention to the changes of mass. On the left, we have an anode, which is zinc. On the right is the cathode, which is copper. As you can see, electrons flow from the anode to the cathode. Over time, the anode becomes smaller and the cathode becomes bigger. Let's zoom in at the cathode to find out. The copper ions in solution is being reduced. It is gaining electrons, becoming copper solid. Now let's zoom in at the anode. As you can see, the zinc solid is being oxidized. It loses 2 electrons, becoming zinc ions, which dissolve in solution. Now let's zoom in at the salt bridge. If you pay attention to the ions, the positive ions is flowing towards the cathode and the negative ions is flowing towards the anode. If you want, you can continue to explore the simulation. The link to the simulation will be in the descriptions. In summary, electrons flow from the anode to the cathode. The cathode will gain in size because it's gaining electrons. The anode will get smaller because it's losing electrons. We will go into details how this happens. Let's look at question 1. Why does electrons flow from zinc to copper? Zinc is more active than copper on table J. Therefore, zinc will be oxidized. It will lose electrons and copper will gain electrons. Question 2. How would you explain why anode is a negative sign and cathode is a positive sign? If you look at this diagram, anode is labeled negative and cathode is labeled positive. At the anode, zinc is being oxidized. It loses 2 electrons, becoming zinc positive 2. Therefore, anode is labeled negative because it is a source of electrons. The electrons will travel through the wire to go to the cathode. So the cathode will be labeled positive because electrons, which are negative, are attracted to positive. In summary, since the redox reaction is spontaneous in a Voltaic cell, the electrons are attracted to the positive cathode. It will travel through the wire to reach the cathode. At the cathode, zinc ion is reduced to zinc solid. Question 3. What ions are present in each half cell's electrolyte? Let's look at the first half cell. It will be zinc ion and sulfate ion. In half cell number 2, it will be copper ion and sulfate ion. Question 4. Which electrode is gaining or losing mass and why? The zinc anode is losing mass because the zinc is being oxidized. It loses 2 electrons, becoming zinc positive 2. Zinc positive 2 will dissolve in solution. The copper cathode is gaining mass because the copper ions in solution will gain 2 electrons, becoming copper solid. Question 5. State the purpose of the salt bridge. The salt bridge allows positive or negative ions to flow between the half cells in order to maintain electrical neutrality of solutions and prevent polarization of the half cells. Question 6. Without the salt bridge, flow of electrons stop. Why is that? Let's get rid of the salt bridge in the diagram. Without the salt bridge, the anode will build up in positive charge over time because of the loss of electrons. In the diagram, zinc is being oxidized. It loses 2 electrons, so over time, the anode will become positive because you're losing electrons. The cathode, on the other hand, will become more negative because it's gaining electrons. So over time, the electrons will travel back to the anode because the anode is becoming more positive and the cathode is becoming more negative. Opposite charge attract, same charge repel. Question 7. Which ions will cross to the other side in the salt bridge? From the previous question, we know over time the anode becomes more positive and the cathode becomes more negative. So which ions have to cross over the salt bridge to prevent polarization? The first step is to identify the ions in the electrolyte solution. In half cell number 1 is zinc ion and sulfate ion. In half cell number 2 is copper ion and sulfate ion. Since the cathode is becoming more negative, a positive ion in half cell number 1 will cross the salt bridge because of opposites attract. The positive ion is zinc positive 2. It is attracted to the negative cathode. Since the anode becomes positive over time, a negative ion in half cell number 2 will cross the salt bridge. The negative ion is sulfate. So in summary, cations, which are positive ions, flow towards the cathode. Anions, which are negative ions, flow towards the anode. Use the catchphrase to help you memorize this. Question 8. The salt bridge was replaced with a porous barrier. Will the Voltaic cell still work? The answer is yes. Porous barrier allows ions to pass through. It is permeable because it serves as a salt bridge. Learning check number 4. Compared to the amount of mass and the total charge at the beginning of a redox reaction, the amount of mass and the total charge upon completion of the reaction is what? Pause the video, resume as completed. The answer is choice 3, conservation of mass and charge. Learning check number 5. Given the overall reaction, as the reaction in this cell takes place, what happens? Pause the video, resume as completed. In this reaction, zinc is being oxidized, so is the anode. Copper is being reduced, so it is the cathode. Over time, the anode loses mass, so the answer is choice 1. The cathode over time gains mass, so choice 2 is wrong. Choice 3 and 4 are wrong because if you look at this redox reaction, copper ion is becoming copper solid, so copper ion concentration decreases, and zinc ion is being formed in this redox reaction, so zinc ion concentration increases. Learning check number 6. Which statement best describes how a salt bridge maintains electrical neutrality in the half cells of an electrochemical cell? Pause the video, resume as completed. The salt bridge allows the ions to go from one half cell to another, so the answer is choice 2. Learning check number 7. Atoms of which element react spontaneously with magnesium positive 2? Pause the video, resume is completed. So you have to use table J on your reference table. When this element reacts with magnesium positive 2, it is oxidized. Therefore, this element must be more active than magnesium on table J. So the answer is choice 2 because barium is more active than magnesium on table J. For practice part 1 on page 24, label the Voltaic cell, write the cell diagram, write the half reaction, and figure out which electrode will increase or decrease in mass. Pause the video, resume is completed. Here are the answers to questions 1 to 4. This concludes the video lesson. Remember to do the Junipod homework.